Hello guys, welcome to the first edition or the first part of the structural analysis tutorial which I introduced about a week ago. So now I've decided to break down the analysis into a couple of videos so that they don't become too long, because concentration is a problem. So if they become a bit short, following the entire tutorial becomes a bit easier. So we are going to have today we're just going to define our materials and our sections for the structure, and then the next tutorial we are going to model the structure. It won't be that long because they would have already defined the material, so we just go into modeling the structure. And then the third one we'll do now a structural analysis of dynamic analysis, earthquake engineering, and all those things, and then so forth. If we don't finish, we'll have another fourth video. So going on to the tutorial. So now this is what this is. I had first introduced this project. This is the project. Here the project is actually a structure which is being constructed here in Clemson. So we're just going to try and model it. This is the architectural view of the front elevation and the 3D the cross section of the building. So the first thing we're going to define our materials, or rather the first thing we're going to create a model. Let's create a new model. And no, we don't want to save this. Okay, we're going to save, create a blank sheet, and then save. We're just going to save it as project 1, and then save it. So if you, let's start with the slabs here. Okay, let's just break down the main components which are on this structure. We have got the slabs, we have got the stairs, we have got beams and columns. If you look into this is the civil engineering drawing. It was already calculated, so we're just going to redo it so that we demonstrate how it's done. So for the columns, as you can see, we have got this type of column which is 40 by 40, and then as you can see here, there is an expansion joint. So they are pretty much they are two structures, but they've got the same foundations. And then we've got this column of 45 by 45, as you can see, and then there is a floating column, this floating column here. Let's see if we can find its dimensions. Okay, the dimensions are not here, so we'll deal with it later. And then we've got veils here, but these ones we'll also deal with them later. We're just going to define the section property, and then everything else will follow. So we've got two types of columns, and then there's this floating column. Let's see if we can actually find its dimensions anyway. Nope, there is no. Okay, it's there. I think it's let's see, I think it's 15 by 15. And then for the beams, we've got two types of beams. We've got the secondary beams. It's written in French here, so it's this is CH. The CH stands for chônage, so it's secondary beam. And then the P1, P2, and these ones, they are the primary beams. So we've got a beam of 30 by 40 centimeters and a beam of 30 by 30 centimeters. I cannot see another one. We've got this one here, BN 30 by 21. So it means that the slab is 21 centimeters. The type of slab which is being used here is the hoodies. They are using hoodies because they're a bit lighter, so they make the building a bit lighter. But we can just use a flat slab which is made of concrete, maybe of 15 centimeters. It's just to our discretion. It is not a problem. So let's go and define our materials. First things first, we are using concrete, so this is a concrete, so we'll modify this material, and if we want we can just rename it concrete, but it doesn't really change anything. So we're renaming it concrete, and then we can change here. Okay, let's just change. Let's say okay, let's show advanced properties. Okay, let's modify here, and then here for the elastic modulus, let's put 32 million. That's the one which we normally use. Okay, let's see if it's okay. It didn't change, so let's say 32 million. Okay, it has changed. And then here for the unit weight, we can just put 25 kilograms per cubic meter. It's a bit more universal. It's being used by a lot of people nowadays. And then for the specific concrete compression strength, we can just stick with 25 megapascals. Everyone knows 25 megapascals. Instead of going for 27, we can just use the 25 and use figures which a lot of people just know. Okay, let's see if our modifications were registered. Okay, so this is now our material. Okay, now let's define our section properties. Let's start with frame sections. Add new property for concrete rectangle. So we're going to start with primary beam, because our slab is a one-way slab, so there's a primary beam and a secondary beam. So primary beam, the primary beam, we said it's a 30 by 40, so it means that the depth is 40, 0.4, because it's a metric system, and 0.3. Now this is a beam, so concrete reinforcement beam. Okay, add copy of property. Now we've got secondary beam. Secondary beam is a 30 by 30. It's a beam. Okay, and then we've got that beam which was denoted BN. It's copy of property. Let's just not change it, we just rename it BN like this. It was 30 by 21, 0.21 like this. Okay, add copy. No, now it's okay. Now we've got our three types of beams. Now let's modify this one. Now the first type of columns, we've got let's say column 1, which is 45 by 45. And then this is a column. Okay, all right. Okay, add copy of property is now column 2. Now this one is 40 by 40. It's very simple. It's funny how much people overpay civil engineers. I'm just joking. All right, now we've got that floating column. Let's just rename it floating column. We say this one is 15 by 15, 0.15. the people who actually calculated this building, they were a bit cautious. That's why they put the floating column. All right. So now we have defined all the columns, 1, 2, and the third one, and we have defined the beams, the primary beam, this one, and then the secondary beam, and then we've got this BN, which is used for the stairs and everything. All right, it's just a supporting beam so that it gives a little bit of stability to the structure. Now we can go on to section properties of our slabs. Now the slab, we can just choose to use a simpler method to just design our slab as a concrete slab, or we can go with the hoodies. But if we go with the hoodies, it means that we will define the slab without any thickness. The software will recognize the slab as a slab, but it will not have any weight, meaning that we will add all the charges or all the weights, the dead loads of the slab onto the slab manually, and then the live loads as well. But then if we just put it as a concrete slab, it means that it will account for its dead load, and then we'll only be adding for what? The live loads. Now that's just a way of just maneuvering around things. But these things, they are all there. I'm using here this was my, let's see. Okay, this is the table of the loads which I imposed on the slabs. It's in French, so in French normally we call it descente de charge. I don't know, I haven't really worked around the name in English. If there's anyone who actually knows, they can just comment in the comment section the name. But now for us, let's just work with the concrete slab. That way the system will just calculate it for us on its own. So add a new section, and then we'll say this is the slab. Okay, it's a thin slab, so we'll make it 15 centimeters. Okay, and then for the stairs is the same. Let's see if there is a copy of the stairs. Okay, it's a copy of the stairs here. Okay, these are the stairs. Let's see the thickness of the stairs. This, okay, 15, 15, and 15. Here to account for these steps, we can just say this one is 15, this one is 15, and this one is 20. It's a scientific guess. It comes with experience. Anyways, let's move on, and then let's use that. And then let's add copy of the section. Now let's say stairs. You can just say stairs 1. Stairs 1 is exactly the same as the slab. And then we can just say stairs 2 for the part where there are steps, and then we make it 20 centimeters. Okay, now what's left to be for the stairs? We've done it. All right, for these concrete walls now, as you can see, they are concrete walls to stabilize the structure from earthquake movements or from shear forces during dynamic movement. So these walls, these concrete walls, they stabilize the structure. Now these concrete walls, they are 20 centimeters because this is the axis. Yes, this is the axis. No, they're 20 centimeters. So add copy of, now say concrete walls. In French they are called voiles. I don't know in English their names. Anyone who can help us, it will be greatly appreciated. All right, okay, Now, from the looks of things, I think we have defined all the major uh, material properties which were used in this structure. Now, from this point forward, we will now be modeling the stairs, the structure itself, combination of the columns and the beams, and then afterwards we will put the loads, and then after the loads we can analyze the structure. So I think I'll end here for today, and then the next time we'll start on the modeling of the structure. Thank you for tuning in, and don't forget to like and subscribe. Cheers.